All right, you guys, here we go. So.
I have a question.
Yes, Sean.
We never got papers.
You guys didn't get papers?
It's not a question. Can we please have papers?
Yes.
Can we please have papers?
Yes, Sean. We're recording, so here we go. It's going to be on YouTube too, so if you watch YouTube, you can hear it.
I'm cool with that.
Okay, so today what we're going to do is really multiply.
Oh, man.
It's called radicals. Radicals is a fancy word for roots. Doesn't really matter, but that's the math word for roots. Any root is called a radical. So we can multiply anything. You can multiply anything. So we're just going to multiply whole numbers with whole numbers, square root numbers, square root numbers. So they're both square root of 3, square root of 6 is square root of 18. And you'd think you're done, but we can also reduce this, right? So let's look at reducing. So we've been doing the reducing for the last couple of years and the last couple of days. I know that there's a 9, square root of 9, square root of 2. I want a perfect square, so I'll reduce it square root of 9, square root of 2. The square root of 2 is just an ugly decimal number, but the square root of 9 is 3. So 3 square root of 2 is my answer. This is as far as I can go with it. I just want to leave it like that, okay? Thumbs up? Okay, good. So number 2 is just a bigger version, that's all. Calculator, oh, can I borrow that back?
108.
Can I borrow that back? Okay, is it 108? Okay, you're ahead of me, I like that. So let's multiply, first of all. So I'm going to get 12 whole numbers with whole numbers. Square root of 18 times 6.
108.
Is it 108? Okay, I'm going to believe you. Don't lie to me. Now, 108's got to have a perfect square in it. I'm going to try 36. I'm not sure, but on my calculator I can take 108, and if I divide it by 36, it works. So that helps. I'm going to take 12 square root of 36, square root of 3, and then I can take the square root of 36, which is 6. 12 times 6 is 72, square root of 3, okay? And I want to leave that as square root of 3 because square root of 3 is a really ugly decimal, irrational number. How about the square root of 3 instead of that ugly decimal, okay? All right, example 3. Am I going too fast? Hi, okay? Bien? Okay, example 3. Multiply whole numbers, 10. Now we're going to have to multiply what's inside the root. I got an 18,
3 times 6.
x to the 12th. Now the square root is like a 1/2 power. It's like a 1/2 power. So we're going to take half of our exponents, okay? So we're going to take half of our exponents. So I'm going to have a 10. I'm going to have an x to the 6th. Took half my exponents. And then I still need to break up the 18, which I did over on the first example. So doing the 18 is not too bad. We've done that already. Square root of 9, square root of 2, right?
Yeah.
And then square root of 9 is a perfect square. It's 3. That's a whole number. 10 times 3 is 30. X to the 6, square root of 2. And I got it. Thumbs up? I'll wait for you, okay? I see 1 thumbs up. 2 thumbs up. Okay, 3, good. Good, good, good. 4. All right, 5. Cool, let's get started. Number 4. So number 4 is cube root, so it's still the same thing. We're going to get a cube root of 54. Well, there might be a perfect cube root in 54. I think 27. Now, of course, the perfect cubes are up there in red. I'm pretty sure it's 27, but if you're not sure, just divide it out, okay? And, yeah, 27 times 2. So I'll rewrite this as the cube root of 27, cube root of 2, and I can take the cube root of 27. It becomes 3. This is not a perfect cube root. It's an ugly number. It is really this. I'd rather not have that decimal, so I'm going to leave it as the
Yeah.
cube.
There's a 2.
There's a 2.
There's a 2 there. Yeah.
There's two
Is it two in
there.
front?
In front
Oh.
of the back.
Oh. Thanks. That's, Lexi, that was why your hand was up, huh?
Yeah.
Thank you. So how about 6 times the cube root of 2? I saw your hand up and I'm like, okay, I'm going to call on Lexi in a second, but you're right. Thank you. And there's a 4 and there's a 2. Okay, thanks, guys. All right, number 5. Let's do the whole numbers, right, Lexi? How about an 8 cube root 48 x to the 9th. Now, the cube root of x, the same thing as x to the 1/3 power. So I need to take a third of that, right? Yeah. So I'll have an x to the 3rd. So I'll have an 8 x to the 3rd. Now 48, probably 8 times 6, right? Because 8's a perfect cube root, so probably cube root of 8, cube root of 6. Okay, I'll let you think about that. So I needed a perfect cube root. I knew 8 was a perfect cube root, and 8's also a multiple of 48.
So wouldn't it be 8 times 8?
That'd be 64, right?
Yeah. 6 times 8.
Right. Right. 6 times 8 is 48, right?
No, but then because isn't it when you factor it? Oh, no.
Okay, good. You know, that's right. Always ask. Okay, cube root of 8 is 2. Let's multiply the whole numbers. So I'm going to have a 16 x cubed times the cube root of 6. All right? How am I doing? Okay? All right. 6. 6, multiply the whole numbers, times the cube root of. Okay, I want to show you a trick. Want to see a trick? I'll show you. 15 is, you don't have to do it this way, but this is sometimes how I do it. 15 is 5 times 3, and the reason I did that is because 25 is 5 times 5, and how many 5s would you see? 3. I don't know if this is going to help you or make it worse. X, 3x. And then, let me keep going, and then I'll explain what I did. You don't have to do it this way, but sometimes this might be easier. 5 times 5, x, 6, x.
Oh, I see what you did. You just broke it down.
So I could have, I see 5, do you see 5 to the 3rd power? Do you see a 5 to the 3rd power?
Yeah.
Which would be the cube root of 5 to the 3rd power, would just be 5.
Yeah.
Did that confuse you or did that help you?
It's something that like we do in our minds.
It's really 5 cubed, isn't it? You can see 5 cubed?
Yeah.
Which the cube root of 5 cubed is 5. Now, if that bothers you, I'm sorry. I also made the cube here. I needed a cube here. I had a 4th, and I made it a cube and a 1. So I can take the 3rd of that one and have an x. I can take a 3rd of that one and have an x2. My 5s are gone because I had 5 cubed. And what's left over? Well, I'd have a cube root of a 3, an x, and another x, right? Which would give me a 30x cubed, cube root of 3x squared. That's one way to do it. You could also just multiply and look for multiples, and that works also. I just wanted to show you a different way to do it, okay? Okay. 4th roots. Well, let's check it out. I'm going to have a 10, multiply your whole numbers, right? 4th root of, I could do the same thing, but I won't. 48, all right? X to the 5th, okay? Now, the 4th root of x is x to the 1/4 power. So I need to take a 4th. But I can't. I can't take a 4th of that without getting a decimal. So I'm going to break it up. So I'm going to do this. 48 is going to be 16 times 3. 16 is a perfect fourth because 2 times 2 times 2 times 2. You with me? 2 times 2 times 2 times 2. And then 6 times 3. I'm going to break this up into the fourth root of x to the fourth with another x left over. Okay, I want you to think about that. I need to take a fourth of the exponent, so I had to make it a number that could be divided by 4. And I have 1 left over. Okay, now let's do some math. That's a 2. That's an x. And the other cube root of 4 can't be done. Cube root of x can't be done. So, multiply my whole numbers. I'll have a 20. I'll have an x. And then I'll have a fourth root of a 3 and an x. Okay, what do you think? Can you do this? Now, 8 and 9 we did last year, so it won't be too hard. 8 and 9 we did last year. We're just going to distribute this times this times this. So I'm going to get 6 square roots of, now if you see a 6 times another 6 and 2, you can do this faster, but I'm going to do it the long way. 72. Do you see a 6 times 2 in this? 6 times 2, which will give you another 6. Anyway, getting ahead of myself. Plus 6 square roots of 6. Okay, think about what I did. I just multiplied whole numbers with whole numbers, square roots with square roots. Okay. 72, I think, is 36 times 2. That's the fastest way. 36 times 2. And I can't do anything with the square root of 6. There are no multiples that work. Square root of 36 is 6. 6 times 6 is 36. Square root of 2 plus 6 square root of 6. Okay. Am I doing okay? Yes.
How'd you get the, so you got 60 square root of 72 plus 6. How'd you get the square root of 6?
Right. So when I multiply these two, in fact, let me highlight them so you can see them better. When I multiply these two right here, right, I've got to multiply the 3 times the 2, but the square root of 6 comes with it.
Right.
So I get a 6 square root of 6, right? Okay. Okay, last but not least, it's just, this one's just FOIL, okay? This one's just FOIL. I'll go slowly. 2 square roots of 2 times 5 square roots of 2 is a 10 square roots of 4, okay? I'll wait. 10 square roots of 4.
Why did the 10 squared before?
Square root of 2, square root of 2. Good question, Lexi. Square root of 2 times square root of 2. So I got my 2 times my 5 is 10. Square root of 2 times square root of 2 is square root of 4.
What about the negative 5 on the end?
We're not there yet. Let's do that now. Let's do that right now. Yeah. Okay, so outside, right? So then I'm going to get whole numbers. Whole numbers, I'm going to get a negative 10. Right? See the whole numbers? And the square root of 2 has to come with it. Okay? So I get the negative 10. The square root of 2 has to come with it. Let's do the inside. Okay? 2 times 5 is 10. Get a positive 10. But the square root of 2 has to come with it. Square root of 2.
Also just do that.
Yeah, it doesn't always though, but this time it does. Yeah. And then last makes a negative 10. Totally right, Thatcher. They do cancel out. Yeah, Reese?
On the last one, is it supposed to be plus 6 square root of 2?
No. Thanks, Reese, for always finding my mistakes. I appreciate you, Reese, a lot. Yes, thank you, Reese. I'm glad you're here, Reese. Okay, now, Thatcher said these two middle roots cancel. You guys agree with that? Negative 10 square root of 2, positive 10 square root of 2, right?
Square root of 4 is
Yep. Square root of 4 is 2.
40 or 20.
10 times 2 is 20. That's minus 10. These are both whole numbers. 20 minus 10 is 10. Okay. That doesn't always work out that way, but in this case, it did. Okay, how's that? Thumbs up, you guys? So we have our next math yet, including our pretty easy homework, okay? We've got 20 minutes to work on this. Go on, stop recording.